Hi everyone, my name's Emma Barnes. I'm Head of Research and Faculty IT at the University of York. So Viking 2 sits within my team. We look after it, but we also do a lot with research software engineers, and just our big push at the moment is sort of sustainable, accessible research IT. So we've always believed that HPC, research IT is for everyone, but we also want to do it sustainably as well.
I'm Richard, I'm one of the assistant directors at the University of York these days, but actually part of some of my favourite places on earth, which is primarily why I'm here, let's be honest. Primarily in computer science, I love cryptanalysis, and I've recently been getting into amateur radio, so there's nothing really better than being here at Bletchley Park. And I had a lovely day yesterday. If you get a chance to stay on, come another time, go up to the Museum of Computing as well. You can actually fill out those crib sheets and break some enigmas. So, without further ado, let's get back on topic.
Just a reminder on questions and then just get past.
Right, so we're actually going to talk today about Viking. So Viking's our high-performance compute facility, and it's, well, we call it the Viking service, so we've had a previous version of Viking, but we installed the new version, Viking 2, and literally sort of went live about a year ago. I remember being at this Sustainable Reality this time last year, getting very excited because we all got a terminal on Viking 2, and I was like, yes, it's alive. So that's where we're focusing this particular talk on, and you know, what's gone well, something what hasn't gone well, or not much actually, and just where we are today. So just a bit of an intro about York. The University of York is a research-intensive Russell Group university. The reason we called our supercomputer, or HPC facility, Viking is because the Vikings invaded York a few times back in the day. So we've got a rich history of sort of with regards to Vikings there, and also it's easy to spell. We've had Egbert, we've had all sorts of Anglo-Saxon names, and spelling's not my forte, so I wanted it simple. I'm part of the research IT team at York. I lead that. It's about 6 years old, so we've been slowly building it up over time and bringing together sort of different people, different skills, and trying to branch out more. Was very kind of physics and CS heavy back in the day, all 6 years ago, but now we're trying to do more in the sort of linguistics, arts and humanities, and other areas like that. And that's the big push on the accessibility side. How can we bring HPC to people as opposed to waiting for them to come to us? We're also fully integrated in IT services, and I've mentioned before we have research software engineers as part of that team. So I'm going to talk to you about the sort of journey we've had to sustainable research IT. It's been an ongoing sort of piece of work we've been doing at the University of York. Started off with, if every department had its own cluster, some of them were in better shape than others. Every department has all sorts of bits of servers and cupboards and things like that. So for many, many years I've been slowly sort of consolidating all that, but also working with the academics to make sure that they are getting what they need and what they want. So it's not IT services comes in and steals everything. That's not what we wanted to do. We wanted IT services to work with people to actually build something better. So we started off with York, which was a complete Frankenstein of a machine, cobbled together of bits of money and bits of random stuff we found in cupboards. We then got an investment of $2.5 million about 6 years ago, where we were able to purchase our first proper HPC facility, and that was the Viking service. So this ran for 5 years. Again, it started off with mostly physicists using it, but as time went on, we ended up having more bioinformatics. We started to get more sort of language and linguistics people using it. And this is free at the point of use, and that ethos is still to this day how we're moving with Viking 2 as well. We also worked with Alcest to actually build and install and look after the machine. So we were a very, very, very small team back then. I think we're all doing about 5 different jobs, and it hasn't changed that much, but it is what it is. Keeps things interesting. But that really worked out well for us because we were able to focus on the user side instead of having to replace hard disks, and this particular bit of kit is broken, we have to fix that now. So we could work with the users to get them onto the machine. We also hosted it in an external data centre as well. So York University didn't have enough power to actually power the thing. And I don't think that's changed either. Nope. So those are some of the challenges we had previously. Now, It's interesting because when we designed Viking 1, we didn't really know what we needed fully. We had some ideas, but we hadn't built anything as big, and we talked to as many people as possible. So that side of things was actually easier in terms of understanding the hardware. We had information, we had stats, we had those relationships. The problem we found was actually hosting it. That's where Richard will tell you about that journey.
Yeah, we don't have a parent campus. We were told, well, we can either build some new student accommodation or you can have your HPC. And you can imagine we surrendered fairly quickly. Student accommodation being the end, be all and end all of university budgets at the moment. So why did we do this? People say, oh, you were very clever to do this. You were very brave to do this. Nah, we had to do it. We had to do it. And that's it. You know, that's the quote, right? Necessity is the mother of invention, or the original quote on need will be the real creator. Electricity, it was a terrible time to be doing this. Electricity became a lot more expensive. I won't tell you what our data centre provider was quoting us for electric, but we couldn't afford to pay it. Our budget, revenue-wise, in terms of what we can afford to pay, ongoing, not increased. You have to make this the same, it has to cost the same as the existing system to run. But we also get the same amount of capital as we got last time. But that buys you loads more stuff now. It consumes a lot more power. And everyone wants GPUs, and they consume a lot of power. So we can't put it on campus. Apologies if there are any UK data centres here today. I'm sure you are inspiring, but the ones we talked to were not inspiring. I mean, one of them, this guy was like, it's my first week at work. No, I don't really know what data centres we've got or anything. And we were like, oh dear. And yeah, cloud obviously was in our minds, but too expensive given the way that we use it pretty much flat out. And also, going back to that, you've got the same amount of revenue as you had before for the electric, and then you've got some capital. Cloud doesn't really fit for us. Coupled with, well, it's batch processing mostly, so why does it have to be so really close to us? Why can't it be somewhere else? We do loads of research that is about the environment. You know, we do climate research. Let's not be doing climate research on something that's changing the climate. You know, you're not meant to change the things that you're measuring, so let's not do that. All the trends that we've all seen. GPUs, lots of them. We've got cryo-EM who are just consuming tons of GPU. We've got AI, machine learning. We all know what a disaster that is for the environment. And also there's the whole water thing as well. You know, AI is consuming an awful lot of the world's drinking water now, which is not a good thing. But also, looking to the future, we're probably going to have to start liquid cooling. We're probably going to have to start doing things like that. We're not going to be able to do that in a UK data centre that doesn't even know what data centres it's got. So I said, well, can't we just put it somewhere cold? And then I handed it over to Emma. Roger. Because that's what you do as an assistant director, apparently. It's not quite true. So we took a little trip out to Falun in Sweden. It's a lovely place. If you ever get a chance to go to Falun, it's nice in autumn, it's nice in winter, actually, which is nice the rest of the year. So we talked to Alsis and we said, Alsis, we want to put our HPC somewhere cold and sustainable. And you went away and you came back and said, oh, we've got this place called the Eco Data Centre. Why don't we go and have a look at it? They were inspiring and competent in a second, third language. I mean, you know, they knew what they were talking about, they were excited about the project, and, you know, so we went and had a look. And that's where our HPC is now. According to the guys at Eco Data Centre. I haven't seen it installed. I went out when it wasn't installed and it was probably still building parts of this. So what does that give us? Well, it gives us sustainability, and that's primarily what we're here to talk about today. The fact that we can actually have a system as well, that's helpful, but sustainability. It's 100% renewable energy. They keep getting more. They built a wind farm. Depends more. It's better than net zero because they reuse the energy. So we do compute, effectively. We're doing compute on a giant heater. That dries out a load of sawdust, that creates pellets, that goes back into the CHP industry. So actually our computing is having minimal impact. The data centre is constructed from wood. We really like that. It is one of the nicest buildings I have ever been in. I wish I lived there, I wish I worked there. It smells great, it feels great, it's just, it's amazing. We just want to put a bunch of computers in it, I don't understand it, you know. Which is fantastic, and that wood comes from the local wood as well. So they're all about minimising the carbon footprint, the environmental impact at every stage. It's not just, oh, I've got some renewable energy, we're done. It's how can we refine every stage of this process? And you'll see in a minute they also report on every stage of the process. The heat's reused, PUE of 1.15, I won't tell you what our local data centres are, but they don't begin with a 1. And we get really comprehensive reporting. So I've stolen some slides from Eco Data Centre, which I don't think they'll mind given I'm advertising them. There's this great website called Electricity Maps, and you can go and look at the carbon intensity of the energy at different times of day across the world. This is just a little example. We're in south central Sweden. Carbon intensity, much better than what we're getting in Britain. And this situation will change, right? There'll probably be some sustainable data centres in Scotland at some point. But a year ago, it was like, we have to go to Sweden. It's great cost-wise. We are paying for power less than what we paid in the UK in 2018. We got a fixed price for 5 years, and they built a new wind farm and gave us a lower price. When did anyone go, would you like cheaper electricity? Well, all right, they're always the time you can have cheaper electricity. They don't actually give you cheaper electricity. And this is partly because the wholesale cost of energy in Sweden is less than a fifth of the cost of wholesale electricity in the UK. They can generate an awful lot of electricity, and frankly, they haven't got a whole lot to do with it. So you get much better pricing. I like that. So what that's meant, you'll find out later, is we can stay within the same budget envelope that we had before, and run a much bigger system. So the idea now is that we start to reduce our on-premise data centres because they are much bigger than we need. I think we're doing about 20% of our US. Somebody went, oh, we're going to have lots more compute in the future. We're going to put it all in this data centre. And of course, we never did because we can't get the electric to do it anyway. And it's not very sustainable. So we're trying to move to this model where actually all the batch processing, all the stuff that doesn't need to be hyperlocal goes out to Sweden. So we start to grow that facility. And essentially, you can buy cloud computing. We're fine with cloud computing if you've got an application for that, that's good. Or you can put something in Sweden. That's good. What we're not going to do is put a load of our GPUs back in our data centre and do all the good work that we've done. Which, was it about a week after we put Viking in, someone went, oh, I'd like to buy a GPU and put it in our data centre. It's a long journey to saying no. I think I mentioned before as well, this data centre, they're designed for HPC. They want heat, they want density, they like it. They've got water and immersion cooling. I think if you look at all of the information that's coming out from the manufacturers, the CPU designers at the moment, in 5 years, air-cooled HPC looking a bit like it's going to be a bit tricky. You're either going to need a lot of space and space it out, or you're going to need your liquid cooling to get that heat out of those systems. And so in Sweden, we've got lots of space, and we can do liquid cooling, and no capital investment from us on that. And then they've got all the good stuff as well. So they've got all the ISO standards that you'd expect, and you can go and see them on the wall. I recommend a visit. And they'll do any scale that you want. So it's just like, when we first went, they're like, would you like your own building? Like, no. No, we're not building that big an HPC, you know. We're not a hyperscaler. But you know, they can do a rack. They can do a row of racks. They can do a locked enclosure. They can do a building. So that's not a problem, and growth isn't a problem, because again, quite frankly, Sweden's got a lot of space. You know, our previous data centre provider, it was like, that's the space you've got. There's probably a spare U in the bottom of that rack, and that's all you can have. Otherwise, we can't guarantee. Whereas now we know we can grow. If we want to replace one rack with a new rack, we can put the new one in and then get rid of the old one, which we wouldn't be able to do where we were. So, what does this look like? So, yeah, got some pictures. You can see our system arriving in Sweden on a lorry. Seems relevant. Viking 1, Viking 2. Essentially, the new system is not massively bigger and faster than the old system, but it's significantly bigger and faster than the old system, and it has a lot more GPUs in it. That's the trend that we're seeing. You know, the CPU of the old system was about what people needed. Obviously, everyone would like things to go faster, but by and large, it was okay. But the GPU demand was growing massively. And we've made a slight switch away from having lots of scratch to having some scratch and some main storage, due to the way that the data was being managed. As Emma said, launched it about a year ago. My first login was from Nando's in Birmingham. We had to move to this new system very much quickly than we had intended to go, due to various reasons in the way we were hosted. But essentially, it was problem-free, wasn't it? That's the takeaway here, the fact it was in Sweden. didn't make a blind bit of difference to you know, how complex the project was. Now, I'm sure that's a lot of hard work from Alsace. I'm just going, oh, it was easy. You wouldn't say it was particularly difficult, would you? It was a straightforward thing to do, and that's the message I'm trying to get across here. It's cheap, sustainable, and actually it's not that difficult. Come and talk to us about you know, import tax and VAT and things like that later, and we'll tell you some of the challenges that you've got to get over thanks to Brexit. But essentially, it was all very doable. And so yeah, Emma's team, working with Alsace, got all the applications installed, got it up and fully used, and there haven't really been any issues. You've done some good stuff with documentation, get all tidied up, and you've got things like open on demand to try and think, and obviously the tweaks to try and get that utilisation up and meet everyone's needs, which is the tricky bit when you've got a whole university to try and make happy, and you've got the people who want to run on a GPU for 4 years without rebooting it, and then you've got the people going, I need 27 GPUs at the same time, and all those little challenges. But not a huge problem. And so yeah, this new system is using that much more power than the old system. Again, getting across that point that we are staying in the same budget, and in fact we're actually spending less than we spent on the old system, but we're using more power. We get these lovely monthly reports from Eco Data Centre, which I really like, because I think if you can think of a possible carbon emission, it's probably on here somewhere. I mean, you'll see that employee commuting is on there, for example. You know, they have bike racks. They all drive Teslas. They do what they can. I don't think they've put mining the lithium for the batteries for the Teslas on here, which would probably ruin things slightly. But apart from that, you get these figures. And if we were using water, we'd get our water figures as well. So this really helps. Firstly, it helps us to demonstrate to our community what's really happening. And it helps keep us honest about the carbon. What it demonstrates, though, is that you consider this system is bigger and faster than the old system. Our carbon usage, we've pretty much worked it out, which really helps, doesn't it? And yeah, Alsace shared this lovely leaderboard with us, the carbon emissions leaderboard. I'm not going to pretend to understand this graph completely. What I can point out is that all the things at the top are all Swedish and they're all ours. If you'd like to be top of this leaderboard, put your HPC in Sweden. Or Iceland, I think I'm supposed to say as well, for contractual reasons. They're all good. We like geothermal, we like wind, it's all good. And already this is starting to have an impact with our research funders, for example. So our cryo-EM team put in a bid for some cryo-EM equipment that I won't pretend to understand. It uses a lot of electric. And what they said in their bid was, we're going to use a lot of electric, but don't worry, because we're going to do our HPC on this Viking 2 thing that somebody else has done for us. And we're going to use that to offset. And the funders really like that. That bid came back as outstanding, got funded, and they specifically raised this point about the fact that we're using renewable energy, hydro, wind, that we're doing these things. So, you know, you might say, well, I don't need to move my HPC. Actually, it's resonating well with our funding groups. And I think that's enough waffle from me. So I'm going to hand back to Emma to tell you the highlights of the journey.
Yeah. So it's been quite a fun and busy year so far. So there's a number of things which has happened. First of all, we won an award. Yay! And that was for a Sustainable Digital Project or Initiative Award. Viking 2 was part of that, but also in IT services we're doing a whole bunch of different things as well. So, you know, just making sure we're turning off PCs at certain times. You know, recycling, making sure that looks, you know, we're using reputable recycling methods for our hardware and things like that. But it's, I think one thing to get across, and one thing we tried to say in this award when we put in for it, was that there's not one solution for anything. So there's not one way to do anything. I think it's going to be a combination of an accumulation of different turning lights off, doing this, doing that. So if you spot something where you can actually improve carbon footprint, improve sustainability, no matter how small or how big, just run with it, go for it. It will sort of contribute and build into the whole piece going forwards. So that was fun, that was great. And as part of that, we were asked to give a talk at I can't remember what it's called, the sustainability event, which is Sizewell running as well. We also did a Viking launch event, yay! And that was really, really fun, where we were able to sort of talk about what we've done, and as part of that we also had some academics talking about some of their research, which I'll expand on in a bit. But we've had a lot of press as well. There's been a lot of just interested people from all sorts of different areas.
We've got page 11 of the Yorkshire Post. I mean, come on.
And so many universities have asked to talk to me about this, and whether they will do it this way, it's up to them really, up to what they need. But it has definitely made people stop and think that actually we don't necessarily need to host our HPC locally. We can do it abroad. We can do things slightly differently. Oh yeah, we've got an H paper. Well, not me, the academics. What I also want to showcase is some of the research that has already happened on this facility. And as I said before, we really push towards this is for everyone. This facility is for everyone. It's not just for the STEM subjects. We are trying to move people towards using HPC more. And Open On Demand and other initiatives we have, good documentation are part of that kind of jigsaw that we're creating. So some of these academics came and actually gave some talks at our launch event. So here, ancient DNA from archaeological grape seeds. So talking about old seeds that people have dug up and looking at how they can tell us about different trading between different groups of people. And really fascinating. I didn't even know you could do that, but really, really good. And all about drinking the wine and how people traded in that regard. Cryo-EM is also another big sort of chunk of research that happens on our facility. So here they actually found a new protein. So this, I don't understand any of this. I'm a physicist background and I have space. But we actually got an Nature paper out of this, and we're able to use our facility to help them do this. Really, really cool. And I've got a little link there, so that's actually the news articles on the website. We also have language and linguistics. So one particular talk was looking at how London English has evolved over time. So obviously London has, big melting pot, a big sort of city where we've got a lot of people moving in and working and sort of establishing lives there, and just looking at the sort of changes in terms of what people are saying, how they're saying it, and that sort of language piece. And now there are sort of multiple generations where there's been actual data taken during that time, so you can actually start to really build up a sort of profile and picture of that. And then we've also got another language and linguistics project, but this was more to do with sort of the kind of other end of things, where we're looking at forensic voice comparisons. So you maybe have someone talking over a phone, or doing something potentially dodgy, and if you say have that person, you can start to match up that actual person you have with that sort of phone message or whatever that is, and start to use that in building a case, for example, if you needed to do that. And then go back to the kind of more traditional end of what we'd see in HPC, where we're looking at crystal structure prediction, but just looking at the different ways in which, and different methods which people are applying to this. So they're looking at using machine learning to actually speed up some of the discoveries. And with Viking, we've got our GPUs now, we've also got our CPUs. I actually think we're doing this work on CPUs, but we've got billions of them, so that's fine. But yeah, it's just a different way of being able to do research we've done before, but because we've got a bigger facility, there are more options now, which is great. And actually, yeah, they were able to do things so significantly quicker on Viking. So, what next? So, obviously we've been running for a year. It's been really good actually, and it's been well received by the users, which obviously is very important, but also the community as well. We've learned new things during that time, so we've realised actually now we've got a lot more GPUs and more CPUs, people want to use Viking even more now. We can never catch up. But this has created bottlenecks in terms of just moving and shifting data over to the facility. So we're actually looking to increase our bandwidth. We currently use a commercial provider early on to provide our networking between the two. At the time we got a 10 gig link put in, but we only use 2 with burstable options. I think we're just going to max it out now. So that's the next piece, because it has created some bottlenecks for some people, so we're trying to iron that out. We're looking at moving other kit there. I'm currently in the process of sort of non-HPC kit, but kind of work for more interactive sessions or just chunks of boxes, which we want to get out of our data centres. Also, I'm obsessed with research data management at the moment. People will be sick of talking to me about it, but I love it. Sorry, Richard. But that's being my bonnet right now. So we're looking to improve data pipelines. The money I've saved from Viking 2, I've reinvested in buying a Globus license. So, that's a whole piece which we're trying to do. Ideally, I want someone to do an experiment in York, and everything is taken care of, goes to Viking, does the processing, deletes what it needs to delete, archive what it needs to archive, and then back again. That's where I want to be, so that's what I'm aiming for. Sustainable RSEs is another part, and just generally tweaking our queues, tweaking our partitions, trying to be making them more efficient. Alsace has built a wonderful monitoring site, so we're starting to incorporate that as well, where we are sending emails to users saying, look how efficient your jobs are, do you really need all that money? Would you like some help? So it's not just about hardware, it's also about the software and that kind of support piece as well. So we're trying to cover all bases.
I think with the sustainability RSCs, what we're looking to do is recognise that we've got some people writing really efficient code. It's been optimised. The physicists have been at it for years. It's great. Okay, fantastic. Lots of people, it's like, it's my first HPC project, and it's really inefficient. So, should we buy another load of GPUs, or should we actually make that code run on half the number that it currently runs on? And so, I employed a couple of people whose job it is essentially to work with researchers to make their code more efficient. The best way to reduce your carbon footprint is not to do the activity at all. So, again, great that we are as sustainable as we can be, but we're now looking at that kind of thing. Because in my career, certainly I've seen some of the code that people write, it's constantly writing to disk, or it's just really badly written. I mean, we had one bit of code that was trying to use 20 terabytes of RAM or something just because somebody hadn't written it right. And funny story, it'll actually run on a Mac. A Mac Mini or a Mac laptop, it runs fine, because it turns out Mac OS doesn't actually allocate the memory until you use it. So this bit of code that wouldn't run on our HPC facility, on Linux, because it needed 20 terabytes of RAM, would run fine on a MacBook. That took some figuring out. But anyway, yeah, sustainability, research software engineers, I think that's really important as well, because we are at that point now where we don't want to be building compute that isn't adding value to the world. We see all the crypto mining, we see all the energy that goes into these things that is just a waste of time. We see all the frivolous uses of AI, and we always say experiment, have fun, that's fine. But the really frivolous end, we want to start getting away from that, and we want to start making our code really efficient.
Brilliant. And that's everything. So if you ever want to talk to us, you know, contact details. Thank you.